Hello again. I wanted to do a quick recording. Recently I had an interview, and this is the second time in an interview I have been asked what I know about DNS. Now, this interviewee, or interviewer, excuse me, I was the interviewee, asked, on a scale of 1 to 10, what would I rate my knowledge of DNS? And I thought about it for a second, having taken extensive networking courses in college, studying for the CCNA and the Net Plus certification. I thought I was about a 6. In my previous videos, I had set up a server, Windows 2019, and I configured a DNS for that domain controller. And I attached other computers to it and ran Active Directory and set up some examples. I still have those videos to come, actually. I'm still in the process of editing them. And I was very confident with this 6. Now, I said this question came up again because a couple of years back, when I was a fledgling service desk enthusiast and aspiring network administrator, I was asked what domain naming system was, what DNS was. And I stupidly said dynamic naming system. I knew exactly what it did. I knew that it translated text to IP addresses, helped you find an internet address like google.com. But that was it. And I didn't really go into too much detail. And so when I responded with this 6, I was confident in having been asked that question before, and I was going to answer it better this time. I had said it in my previous videos, domain naming system, and this is what it does. And that is what it does. It's a fundamental component of the internet that translates human-readable domain names like this.com into IP addresses like 192.0.2.1. Ignore the fact that that is a Class C IPv4 and would not be used for the internet that computers use to identify each other on the network. I thought, for the most part, that was pretty much it. And then he asked me another question. He goes, what do you know about DNS records? And my mind raced. I thought to myself, oh, I know about, caches, queries. If I type in google.com, it's not going to query the server for what IP Google is attached to because it's already been looked for before. It's just going to go into the cache, and it's going to find that IP address. And then he started saying names of files, and suddenly that 6 started to shrink to about a 3 out of 10. So I made this little slideshow, and I educated myself a little further, and I wasn't too bad off, but I could know more, and as such I wanted to just relay a little bit of this information to my viewers and further educate them, and hopefully they won't run into this situation. And now I don't know that I blew this interview. In my opinion, I did. That was, I was saying that I wanted to be a network administrator, and perhaps my focus should have been on some of the earlier items within that realm. If I am setting up my own server, if I'm doing some network systems administration, that is, I should understand what's going on with DNS. So I further educated myself. And here are the records that he was asking about. A records maps the domain to the IPv4 address. AAAA records maps the domain to an IPv6. Now IPv6 is a hexadecimal address system. There are many domains and servers that are converting from IPv4 to IPv6 because IPv6 has vastly more address allocations than IPv4 does, and subnetting is much easier on it. We have our CNAME record, alias of one name to another. For example, example.com could be www.example.com. Kind of helps you streamline your queries. Your MX records specifies mail servers for the domain. Your TXT records holds text informations related to the domain. And your NS name server record delegates a DNS zone to use the given authoritative name servers. So yes, there was much more to DNS than I suspected. So we're going to go into a little bit of detail on that right now. I do keep my videos fairly short and digestible, so I will not bore you too much. So moving in, domain names. Human readable addresses for websites, www.google.com. I've used this one before. Organized in a hierarchical structure with multiple levels. IP addresses can be IPv4, like we mentioned before, and the hexadecimal IPv6. And here's the DNS hierarchy. We have root level. It's the top level DNS hierarchy, represented by the dot. Top level domains, TLDs, which is the next level. It's either going to be the COM, org, net, or country specific, like UK or JP. Second level domains, directly below TLDs, the example in example.com, or this in this.com, as I put earlier. And then subdomains, additional parts, the www, or for in this example, www.example.com, which comes up a lot. So as I mentioned before, I did set up my home server lab, and I'm experimenting a little bit with Active Directory and domain controllers. And essentially what domain controllers do is you set up group policies and you allow access to apps, or you host the apps that your clients can have access to or limited access to. And Active Directory uses DNS to locate domain controllers. When a client, that's why you would attach everyone to the DNS, like I did when we did the DNS when we were setting up our Active Directory service. When a client or another server needs to find a domain controller for authentication or other Active Directory services, it queries the DNS to get the IP address of the domain controller. So, if I am Tom in accounting and I want to access the shared version of QuickBooks, which is being hosted, I would log in, and that would then query the DNS, which would find the domain controller that would have that and connect me to it. When a client or another server needs to interact with Active Directory services, such as authentication, querying directory information, or accessing resources, like in the example I just gave, it must locate a domain controller that can provide these servers. DNS plays a crucial role in that. We'll go through a little example of how that query works now. In this scenario, a user attempts to log in to a Windows client machine that is part of the this.com domain that we've used earlier. The DNS will query for a service record. Service records are a type of DNS record that define the location, the host name, port number, of servers for a specific service. In this case, we're looking for the lightweight directory access protocol, which will allow a user to log in. So the DNS queries for the service record. The client machine queries DNS for the lightweight directory access protocol, in this case using TCP. We definitely want to have that checksum if we're verifying a user's identification for the domain this.com. Then the DS responds with these service records. It could be multiple. In this case, we have two. A little breakdown of what this information essentially is we have the service, which is LDAP, Lightweight Directory Access Protocol, the protocol of transportation I said earlier, which was TCP, so we definitely want that checksum. The domain to which the service record applies, which is this.com. Time to live indicates how long the record should be cached by the DNS resolver. And that, in this case, it's 600, which is 600 seconds, which is roughly 10 minutes. The class of the DNS record, typically IN for Internet. In this case, it is IN for Internet. The priority. Lower values are preferred. And multiple servers provide the same service, the one with the lowest priority is tried first. So, in this case, it's 0. Then we have a relative weight for entries with the same priority. Higher values have a higher chance of being selected for this one. In this case, we have a priority of 100. Then we have the port for the service that's being hosted, which of course is 389, and we have it on two different domain controllers for this.com. We have domain controller 1 and domain controller 2. So then the DNS queries for an A or an AAA record, which again, if you remember, gives it the IP address, either IPv4 or IPv6. It will return the IP address. In this instance, it's 192.168.1.1, and then it connects to the domain controller and allows access. In which case, Kerberos would then issue a ticket to that particular user, and then when he or she wants to access anything else, they won't have to go through this same process of querying because they'll already have a ticket to access. So this is a much more in-depth look at DNS. It shows that, my confidence level was pretty good, but it wasn't where it needed to be. After doing this, I can confidently say I'm about a 7 now out of 10. There's a lot more to learn. There are a lot more records. There's a lot more queries. There's a lot more information that you can do using PowerShell to manipulate records and change records. And also, this falls into the realm of security, where we can secure that DNS cache from being poisoned by an outside source and redirecting our users to malicious websites. I hope you found this as fun as I did. I always enjoy learning new things, and it felt like a challenge when I was hit with that little roadblock. And going forward, if I land this position, I'll have to be very grateful to my interviewer, because he challenged me, and I went and met his challenge, and I'm still learning. But if I didn't, I am prepared a lot better for the next interview. Thanks again for listening.